Are you a student who is going to start the IB diploma program in the coming year? You must have chosen one of the 4 options for mathematics: analysis and approaches, or application and interpretation, either HL or SL in one of them. Whichever course you have chosen for mathematics, you are expected to have a thorough knowledge on certain concepts before entering the course. These concepts are listed by the IB in their subject guide for mathematics as prior learning topics. The topics covered here are numbers, algebra, functions, trigonometry, geometry, statistics, and probability. The concepts listed here will not be taught in your DP lessons, and not knowing these might slow down your learning process in DP maths classes. Hence, I have decided to walk you through all these concepts as quickly and as effectively as possible in the next few videos. I will cover 1 or 2 topics in one video and give a brief explanation of each concept. If you need any detailed explanation of any concepts, you will be directed to the links to that video in the description box below. Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, we are going to see the prior learning concepts under the topic numbers for IB Maths AA and AI. And this is common for both higher level and standard level courses. This video is pretty long, therefore timestamps are given for this video so that you can jump to any chapter you wish to watch. But I would sincerely advise you to watch and listen to each part of this video carefully, because even if the topics look simple and of primary grade level, there are certain important tips that you need to consider for applying them in DP Maths classes. Before we proceed further, let's understand that the International Baccalaureate uses the notation system called International Organization for Standardization, otherwise called ISO standards. So let's see what's in the number system. Under the number system, you should have known all the number sets: natural numbers, integers, rational numbers, irrational numbers, and real numbers. These are the different number sets that you would have learned in your earlier years. We will see what are these in detail. Natural number set is a set containing the elements 0, 1, 2, 3, etc. Notice that 0 is an element of natural number set. In your previous years, you would have learned that 1, 2, 3, etc. are natural numbers. But here we add 0 to the natural number because we are following ISO standards. According to ISO standards that IB follows, we have 0 in the natural number set. So make a note of this. And how do we write the set? We write the set with a cross over the capital letters as shown here. For example, natural number will be written with a cross over the capital N. This cross denotes that we are specifically talking about the number sets, not any other set with capital N. So if you put the cross over capital N, it is understood that you are talking about natural numbers. So if you want to say that X belongs to capital N, instead of just writing capital N, if you put the cross, it is understood that X is a natural number. So let's proceed further to see what are integers. Obviously, integers are natural numbers, but added to it is all the negative numbers. So natural numbers along with the negative numbers will be integers. So 0 plus or minus 1 plus or minus 2 plus or minus 3, etc. are integers. And set of positive integers is z plus, which will have the elements 1, 2, 3, etc. 0 is not positive and it is not negative as well. So z minus will not have 0 as well. It will have negative 1, negative 2, negative 3, etc., which we are not going to use often, but z plus is a set which is used often in DP classes. Therefore z plus means it is a set containing the numbers 1, 2, 3, etc., whereas the set of natural number is a set containing the elements 0, 1, 2, 3, etc. So make a note of these 2 sets now. Next, we'll move on to rational numbers. We know that rational numbers are fractions, right? Fractions in the form p over q, where q is not equal to 0. This is what you would have learned in your previous years. But in DP, it might be helpful to learn that rational numbers are terminating or repeating decimals. Any fraction is either terminating or repeating. For example, 3 over 5 can be written as 0.6. This is a decimal which is terminating. So this is a terminating decimal which is a rational number. Another rational number, say for example 2 over 3, can be written in decimal form as 0.666, etc. You can see that this is a repeating decimal. So either repeating or terminating decimals are rational numbers in decimal form. So it's either fraction, or in decimal form it should be terminating or repeating decimals. Why is it important to write this for decimals? This is because for irrational numbers, we define irrational numbers as non-terminating and non-repeating decimals. You must have learned that irrational numbers are square root numbers with pi, etc., right? It's not just square root numbers. If you expand the square root numbers, you'll see that they are non-terminating or non-repeating decimals. So such decimal numbers are called irrational numbers by definition of irrational numbers. So before we move on to real numbers, let's see the connection between these four sets. First set, the smallest set, is set of natural numbers, right? 0, 1, 2, 3, etc. This is the first set that was formed by humans. If you include negative numbers into this natural number set, you will get integers. Therefore, natural number set is a subset of integers. The set of integers is bigger than the set of natural numbers. And any integer, say for example 2, can be written as a fraction, 6 over 3. So any integer can be written as a fraction. Therefore, every integer is a rational number. Therefore, rational number is a bigger set than the integer set. Therefore, natural number is inside this integer set, and integer set is inside the rational number set. So, natural number set is a subset of integers. Integers is a subset of rational numbers. So, rational number set is the biggest set we have among these three sets. Next is irrational number set, which is separate from the rational number set. But if you combine these two sets together, we get the set of real numbers. So real numbers are nothing but the union of rational and irrational numbers. So if you have both rational and irrational numbers together, we call them as real numbers. And within the rational numbers, we have the set of integers, and within the integers, we have the set of natural numbers. Therefore, if you combine rational and irrational together, you can say that the numbers formed are real numbers. Before we proceed further, we need to understand what is R plus. R is the set of real numbers, plus is the set of positive numbers. Therefore, R plus should be a set of positive real numbers. What's the big deal about it? We have that 0 is neither positive nor negative, right? So R plus is a positive real number. If x belongs to R plus, we can say that x is not equal to 0 because 0 is not positive. Therefore, R plus does not contain 0. So you should write x greater than 0 if you want to represent all positive real numbers. So x strictly greater than 0, and x is not greater than or equal to 0. So x is not equal to 0 but strictly greater than 0, just above 0. It could be 0.0001 as well, but not equal to 0. So if you want to say that R plus is a set of positive real numbers, you have to say that x is strictly greater than 0, which also means that all numbers just above 0. This is important because most of the questions are based on R plus set. Therefore, R plus and Z plus are some commonly used sets in IBDP classes. So make a note of this. R plus is a set of positive real numbers which does not contain 0 but all numbers just above 0. And Z plus is a set of positive integers which contains 1, 2, 3, etc. It also doesn't contain 0. So these are the two things that you need to note before we go further. The next part is SI system of units. I will be giving you the units for different quantities now. You just make a note of this. There is nothing to explain in here. Mass is measured in kilograms, length is measured in meters, time is measured in seconds. Therefore, velocity and acceleration are measured in meters per second and meters per second square. Area and volume are square meter and cubic meters. So everything will be in terms of meters for length, in terms of seconds for time, and in terms of kilograms for mass. This is what you need to take away from this point. Let's proceed further. Next is how to approximate numbers in different methods. First is rounding numbers to tens, hundreds, thousands, etc. The next is decimal approximation, which means you have to round off a decimal number to 1 decimal place, 2 decimal places, 3 decimal places, etc. The next is significant figures, which is most important for DP classes. You have to round off any non-exact answers to 3 significant figures in DP maths exams as well as in the classes. First is rounding numbers. So let's round a number to nearest 10, 100, etc. Let's consider this number 2146. So make a note of this, that whenever you are approximating, you need to use this symbol, approximation symbol, before the answer that you are going to give. So for example, 2146 to nearest tens will be 2150 because 46 to the nearest 10 is 50. So 2150 is the nearest 10 of 2146 approximated to. So the symbol approximation is there. I'm going to use the symbol again. Approximated to nearest 100, the answer is 2100. Approximated to nearest 1000, it is 2000. I think you must have learnt all these things in grade 7 or grade 8, so you must be knowing all these things very well. So let me proceed to decimal approximations, which is more common in DP classes. Approximating decimals to 1 decimal place, 2 decimal places, etc. Let's consider an example, 12.8542. Now let's approximate to 1 decimal place. It's a decimal number, therefore we can approximate this to 1 decimal place. To 1 decimal place, you have to look into the second decimal place, which is 5. Any number 5 and more than 5 will change the previous number by adding 1 to it. So the second decimal place has a 5, therefore it will add 1 to the 8 before that, making the approximation as 12.9 to 1 decimal place. To 2 decimal place, try to do it to 2 decimal place now before you continue with this video. If you are ready, continue with the video. I'm going to give you the answer to 2 decimal places and also to 3 decimal places. Are you ready? The answer for 2 decimal place is 12.85 because the third decimal place is 4. It doesn't change the 5 there. To 3 decimal places, it is 12.854. Again, it's 2 is in the fourth decimal place. It doesn't change the 4 in the third decimal place. So 12.854, and I hope you got all these answers correct. In the case where you have 12.954, so this is something important that you need to note. Even though you know how to round it off to decimal places, what you need to know is how to write your answers properly. In this case, 12.9542 is approximated to 13.0 for 1 decimal place. Notice that 0 is shown there, even though it doesn't have any value. 13.0 should be your answer because you have to show that you have rounded this off to 1 decimal place. So you have to put that decimal place number there. In this case, the number in the first decimal place is 0. Therefore, it has to be shown in the answers. So writing the answers appropriately is also very important in DP mathematics course. Therefore, 12.9542 approximated to 1 decimal place should be written as 13.0 and not 13. Got it? Let's move on to significant figures, which is most significant for DP maths classes. Significant figures can be to 1 significant figure, 2 significant figures, or 3 significant figures, but the most common thing is 3 significant figures for DP classes. Let's consider this example, 25,492. 2 is the first significant figure on the left side. Next, second significant is the 5, third is 4, fourth significant figure is 9, and the last significant figure is the 2 on the right side. Again, I'm using the symbol approximation here because I'm going to approximate this to 1 significant figure first. The first significant figure is 2. The next number is 5. Therefore, it will change the 2 to 3, making the number as 30,000. So, it is approximated to 30,000 to 1 significant figure. Now, try to do this for 2 significant figures and 3 significant figures. So, 25,492. When you are rounding off the significant figure, the remaining numbers will become 0. So, make a note of this. So 2 significant figures, the answer is 25,000 because third significant figure is 4. It doesn't change the 5 there. Therefore, 25 remains as it is. The remaining numbers will be zeros. Therefore, 25,000 will be the answer for rounding off 25,492 to 2 significant figures. Are you ready for 3 significant figures? 25500, 25,500 because the 9 makes the 4 to 5. So 25,500 will be the answer for 3 significant figures. And this 3 significant figures is very important for DP maths classes. Make a note of this. Learn this properly now. Let me give you one more example with decimals. 4.982 again is approximated to 5.0 to 2 significant figures because the 8 makes 9 as 0 and consequently 4 becomes 5. Therefore, 5.0, even though this is equal to 5, you are not supposed to give the answer as 5. You are supposed to give the answer as 5.0 if you are giving the answer to 2 significant figures. Let's proceed further to the next example where you have zeros after decimal place. The first significant figure in this number is 5. The next significant figure is 9. Next is 6. Next is 3, and it goes on like that. If you want to approximate this to 2 significant figures, the third significant figure is 6, therefore it will add 1 to the 9. Subsequently, that will add 1 to 5, which makes it 60. 60, so 0.0060 will be the approximation of the given number to 2 significant figures. Try to write this for 3 significant figures. Are you ready? I'm going to give you the answer for 3 significant figures here, which will be 0.00596. The 3 doesn't change anything. Therefore, the answer for approximating this number to 3 significant figure is 0.00596. What you need to note here is the first significant figure is the first number after all the zeros. If you want to learn more about approximation of numbers, there is a detailed video in this channel for which the link is given in the description box below. So you can click on the link, watch this video before you proceed further if you want to learn more about approximating numbers. Next is absolute values. What are absolute values of a number? It is denoted by modulus of A. A is a number. If there is a number A, then the notation for absolute value is called modulus of the number, which is written with 2 straight lines on either side of the number. And the meaning of absolute value is we are considering only the positive value of the number. So absolute value can never give you a negative value. The definition of absolute value is if there is a number A, absolute value of A is A itself if it is a positive number. Absolute value of a negative number is negative A. So I'll give you an example to show what it means. If you have modulus of 3, 3 is a positive number. So modulus of 3 is 3 itself because A is positive here. A is 3. Because A is positive, modulus of A is equal to A itself. So modulus of 3 is equal to 3 itself. Whereas modulus of negative 3, because A is negative now, it will be equal to negative A. So negative of negative 3, which will become positive 3. So you can notice that modulus of 3 and modulus of negative 3 both give you the answer as positive 3. Therefore, the modulus of any number is greater than or equal to 0. If A is 0, it will be equal to 0. So modulus of A is always positive. It can never be negative. If you want to learn more about absolute values, you need to register in the website ganitika.com. With your name and valid email ID. You have a full description about absolute values of different types of numbers in this website. Proceeding further, the next thing that you need to know is operation on numbers, which is going to be very easy for you: addition, subtraction, multiplication and division on integers, rational numbers and irrational numbers. First of all, let's have a quick look on integers. Integers, since they have both positive and negative, there might be slight problem with adding or subtracting positive negative numbers in most of us. So 2 plus negative 3 is negative 1. 2 minus negative 3 is negative 5. 2 times negative 3 is negative 6. These are just examples I'm giving you. But if you want to learn more, there is a video in this channel for which the link is given below. So adding 2 integers, subtracting 2 integers, multiplying 2 integers and dividing 2 integers. And you must have learned this in your primary classes. So I'm not going to go in detail about this. But next is rational numbers, which are fractions. So adding, subtracting, multiplying fractions. First is adding and subtracting. For this, you need to use the common denominator method. So if you want to add 2 fractions, you need to make them into common denominator like this. And then add the numerators, put the common denominator. This is what you must have learned in your earlier years. You just need to refresh your memory on this. Next is multiplication. Once you multiply, you need to simplify. The answer should be in the simplest form. Let's take an example. 2 over 3 times 9 over 8. You can simplify this by cross multiplying and the answer is 3 over 4. You can also multiply directly and then divide both of them by the common factor and then simplify to get the same answer. So either way is okay, but the final answer should be in the simplest form. Next is division of 2 fractions. When you want to divide 2 fractions, you will multiply the reciprocal of the second fraction and do the same multiplication method and simplify the answer. This is again which you have learned long back. But if you want to learn more about operation on integers and addition, subtraction, multiplication and division on fractions, that is operation on fractions, there are videos in the channel and the links are given in the description box below. Next is operation on numbers on irrational numbers. So irrational numbers are square root numbers, which are also called surds. So for adding and subtracting 2 surds, they have to be of same type. For example, you cannot add square root 2 and square root 3 because they are different surds. You cannot add them. So both the surds should be the same. For example, you can add 2 square root 2 plus 3 square root 2 because square root 2 is the surd here. So they have the same surd. 2 square root 2 plus 3 square root 2 is 2 plus 3 is 5. There are 5 square root of 2 in this case. The same thing goes for subtraction as well. 2 square root of 3 minus 3 square root of 3. The surd is the square root of 3 here. So subtracting them, 2 minus 3 is minus 1. Therefore, 2 square root of 3 minus 3 square root of 3 should be equal to negative square root of 3. So this is subtraction of irrational numbers. Multiplication of irrational numbers, just multiply the numbers inside the square root and put the square root symbol over them. That's easy. If you have a complicated surd like 3 square root of 2 times 4 square root of 5, you have to multiply the non-square roots and then multiply the square roots as you did before. So 3 times 4 is 12. Square root 2 times square root 5 is square root 10. So 12 square root 10 will be the answer for this. This again you would have learnt it in earlier years. Division of surds, square root 2 divided by square root 3. So you will write it like this if you don't want to change the denominator. But if you want to rationalize the denominator, you will multiply both numerator and denominator by the denominator, which means you will get the denominator into a rational number, 3 in this case. So again, if you want to understand what is rationalizing irrational denominators, you have a video in this channel for which the link is given in the description box below. Next, prime numbers, which is most important here because you will be factorizing numbers into prime factors and you will be finding HCF and LCM at many places. What are prime numbers? Prime numbers are those numbers which are divisible by 1 and the number themselves. So they cannot be divided by any other number other than 1 and the number itself. They are called prime numbers. The numbers are 2, 3, 5, 7, 11, etc. You have learned these things, but what you need to note here is 1 is not a prime number. The first prime number is 2 and the only even prime number is 2. So 2 is the first prime number, 1 is not a prime number. Remember this, whenever you are given a set of prime numbers in your questions, you should notice that 1 doesn't belong to the set of prime numbers. The minimum number is 2. Next is prime factors. What is prime factors or prime factorization? Writing numbers as a product of prime numbers. For example, you can write 60 as 2 times 2 times 5 times 3. So writing 60 as a product of prime numbers is called prime factorization, and these numbers are called prime factors of 60. 2, 5 and 3 are the prime factors for 60. Next is HCF and LCM. HCF means highest common factor and LCM means lowest common multiple. This can be done for 2 or more numbers. Let's look into some examples for both. What is HCF of 24 and 45? For this, you need to prime factorize 24 and 45 and find the common factor, which is 3 in this case. Therefore, the highest common factor for 24 and 45 is 3. Let's consider another example, HCF of 30 and 54. In this case, if you prime factorize both of them and choose the common factors, you are getting more than one common factor, 3 and 2 in this case. So in order to find the highest common factor, you need to multiply both the common factors. So the HCF of 30 and 54 is 6. Next is LCM. LCM of 15 and 12. For this, you will use the method called division method. Find the common factor for 15 and 12, which is 3 in this case. So dividing 15 by 3, you will get 5. Dividing 12 by 3, you will get 4. And you need to just multiply 3, 5 and 4. You stop at 5 and 4 because there is no common factor between 5 and 4. So you stop the division there. So the numbers that you have to choose are 3 and 5 and 4. Just multiply them all. You will get the least common multiple of 15 and 12, which is equal to 60. So if you start finding the multiples of 15 and finding the multiples of 12, the first number that is common to both the multiples will be equal to 60. But if you want to find the LCM of 5 and 12, there is no common factor for 5 and 12, so you cannot use the division method here. Instead, you will simply multiply the two numbers 5 and 12. So the first common multiple for 5 and 12 will be 60. It is interesting to note that LCM of 15, 12 and LCM of 5, 12 is the same and it is equal to 60. Why so? Can you think about it? In order to learn more about prime numbers, prime factors, HCF and LCM, there is a link to the video in the description box below which explains clearly all about these prime numbers and how to find LCM and HCF for different numbers. Let's proceed further to the next topic in numbers, ratio, percentage and proportion. Ratio is comparing two quantities, whereas proportion is comparing two ratios, and percentage is finding the ratio out of 100. So if you multiply the ratio by 100, you will find percentage. Again, you learned this in very early stages, but we'll be using all these things in simple application in DP classes. So let me start with this picture. There is the original Eiffel Tower and a model of this. The model's height is 16 centimeters, whereas the original Eiffel Tower is 324 meters. Now, if I want to find the ratio of their heights, I need to change the units to be the same, because in this case I have 16 in centimeters and 324 in meters. So it's easy to convert meters to centimeters rather than centimeters to meters, right? Because centimeters to meters will give you decimal numbers. We don't want decimal numbers. Instead, we will change the meters to centimeters as 32,400 centimeters. Now you can compare the height of the model with the height of the original Eiffel Tower, as 16 is to 32,400. You can also write this as fraction, 16 over 32,400. So this is the ratio of the heights of the two pictures here. Now if I'm given the width of the model as 5 centimeters, using this I want to find the width of the original tower. This becomes a proportion question. So because we are comparing the ratios of the two pictures, therefore this is called a problem on proportion. You simply have to write the ratio of the model to the ratio of the tower. You can notice that I'm not using 32,400, I'm using 324, but I'm using 16 on the left hand side. Why am I using like this? Because the units on both the sides are the same, so it will get cancelled. So I don't have to worry about the unit. As long as the units on either side are the same, it's okay. Now simplifying this, cross multiplying and simplifying and finding x, you will get x as 101.25 meters, and I'm not sure if this is the correct width of the Eiffel Tower. I just gave you an example as 5 centimeters. So proceeding to percentages, if I want to find the percentage of the ratio of the heights, I'll simply multiply the ratio by 100, and which is approximately equal to 0.05. Again notice the approximate symbol, because I'm rounding this off to one significant figure. 0.05%. So the model is 0.05% of the dimension of the original Eiffel Tower. In order to learn more about ratio, proportions and percentages, you can visit Ganitika.com. Under the topics page, you have this chapter called ratio, percentage and proportion, and everything is explained clearly in this chapter. So let's proceed further. The next part of numbers is inequalities. Less than or equal to, greater than and greater than or equal to. So these are the symbols that you need to know for different inequalities. You should be knowing how to represent the inequalities on a number line like this. So if you want to represent all the numbers less than 2, you will put a circle over 2 and write this as x. The arrow mark towards the left of the circle will represent x less than 2. And if you want to show x less than or equal to 2, you will just shade the circle and put the arrow on the left side and making this as x less than or equal to 2. Whereas for x greater than 2, on the number line you will put an open circle because it's not equal to 2. Therefore you will put the open circle, but the arrow mark will be to the right of 2, which shows that x is greater than 2. All the numbers greater than 2 will be to the right of 2. Similarly, x greater than or equal to 2 will be the shaded circle with the right side arrow mark. More on number line and interval notations can be seen in the video, for which the link is given in the description box below. Next topic under numbers is standard form. Writing a number in standard form means writing it as a times 10 to the power of k, where a is a number between 1 and 10 and k is an integer. So let's see some examples on how to write 35,000 in standard form. Notice that I'm putting equal to, I'm not approximating it, I'm just writing this in standard form. In order to write this in standard form, first of all you need to find what is a. A should be a number less than 10. So if you put a decimal point after 3 and before 5, you get 3.5 as a, and then this can be represented as 3.5 times 10 to the power of 4, which will give you 35,000. So writing 35,000 in standard form is 3.5 times 10 to the power of 4. You can notice that a is 3.5, which is less than 10, and k is an integer equal to 4. Next number is a decimal, 148.25. So you need to give an answer with number less than 10. Therefore, you will move the decimal place backwards to 1.4825 and then multiply this by 10 to the power of 2. You will get 148.25. Therefore, this is the standard form. Notice that a is 1.4825, which is less than 10, and k is an integer. Going further with a more decimal number, you can see that 0.00254, it has to be more than 1. A should be more than 1. Therefore, the decimal should be moved all the way to after 2. 2.54 times 10 to the power of negative 3. In this case, a is 2.54, which is less than 10 and more than 1. K is negative 3, which is an integer. Next is 138 times 10 to the power of negative 7. It looks like as if it is already in standard form, right? But you can notice that 138 is not less than 10. It is more than 10, therefore this is not in standard form. So you have to change 138 to a number which is less than 10 and more than 1, which will be 1.38. And therefore changing the 10 to the power of negative 7 to negative 5, you will get the original number. So here you can see that A is 1.38 and K is negative 5. 1.3 is it's more than 1 and less than 10, so it's okay for A. K is an integer. So this is how you change the numbers to standard form, and I hope you enjoyed watching this video. Thanks for watching. Subscribe to this channel and like and share my videos with your friends and families. Thank you very much.